So this is in your notes. This is not on the note sheet that I gave you yet. So as a warm-up today, let's do these two as a sum and difference. You right now as a warm-up, find me the cosine of 75 degrees and the sine of 5 pi over 12 as a sum or a difference. That's using identities 18 through 20 on your identity sheet. All right, cosine of 75 degrees would be the cosine of 45 plus 30. Okay, so that's a bad 45. Okay, so then that's going to be cosine of 45 cosine of 30 minus, because it was a sum, sine of 45 sine of 30. Cosine minus sine. Yep, cosine at 45 degrees is root 2 over 2. Cosine at 30 degrees is root 3 over 2. Sine at 45 degrees is root 2 over 2. Sine at 30 degrees is 1/2. So then that's going to give me the square root of 6 over 4 minus the square root of 2 over 4. So I get that the cosine of 75 degrees is the square root of 6 minus the square root of 2 all over 4. Agree? Okay. Sine of 5 pi over 12, I'm going to go with, this is the sine of 3 pi over 4 minus pi over 3. 3 pi over 4 is 9 pi over 12. Pi over 3 is 4 pi over 12. So 9 pi's over 12 minus 4 pi's over 12 gives me 5 pi's over 12. So this is sine, so then that is the sine of 3 pi over 4 cosine of pi over 3 minus cosine of 3 pi over 4 sine of pi over 3. Sine at 3 pi over 4 is root 2 over 2. Cosine at pi over 3 is 1/2. Cosine at 3 pi over 4 is negative root 2 over 2. And the sine at pi over 3 is root 3 over 2. That gives me then square root of 2 over 4 minus negative square root of 6 over 4. So I get that the sine of 5 pi over 12 is the square root of 2 plus the square root of 6 all over 4. Questions, comments, concerns, clarifications for either one of those? Seeing, hearing none. Let's go into half angles. We did one example yesterday of a half angle. Still on your own. This is still not on your note sheet yet. Okay. So let's do together. Let's do tangent of 7 pi over 12, and then I'll switch it up here momentarily on this one. I'm going to take it off of tangent, and I'm going to make it be something else. Okay? So tangent using a half angle, so then this would become the tangent of 7 pi over 6 divided by 2. 7 pi over 6 divided by 2 is 7 pi over 12. Okay? 7 pi over 12 is not on the unit circle, otherwise we wouldn't have to do this, but 7 pi over 6 is. Okay? So now on your identity sheet, I'm looking at numbers 24 through 26. Number 26 is the tangent ones. It gives us 3 choices there for it. Which one would you like to use? Option A, option B, or option C? Why B, Mace?
I don't know.
Because there's what? Because there's no square root for 1. So option C would be choice of last resort, by all means, because there's a square root. Okay? And there's a fraction within the square root, so you know you're going to have to rationalize no matter what. Okay? So for sure, option C, last resort. I agree with that. Okay? Why option B instead of option A? I would choose option B too, just so you know.
Yes.
Full disclosure. Looking at it, why is option B, the middle one there, why is that better than the first one?
Because at 7 pi over 6, you'd have to, if cosine was in the denominator, you'd have to like rationalize it.
Because there would be a radical down there, right? Yeah, okay. Otherwise known too as the fact that option B has just one term in the denominator. So it's literally just a keep, change, flip. Okay? Option A has a binomial in the denominator, so you're going to have to multiply through by a conjugate. Okay? Right? So for sure, option B here. So we're going to go with tangent of that. So my tangent here, I'm going to go with tangent of u over 2 is equal to 1 minus the cosine of u all over the sine of u. Okay? So u now is 7 pi over 6. Okay? So then that's going to become 1 minus, what is the cosine at 7 pi over 6? Negative root 3 over 2? Divided by the sine at 7 pi over 6. What is the sine at 7 pi over 6? Negative 1/2. Okay. So this really is 1 plus the square root 3 over 2 divided by negative 1/2. Do we agree with that? Okay. Keep, change, flip tells me that this is going to be 1 plus the square root 3 over 2 times, that's my keep, that's my change, times negative 2 over 1. Do we agree with that? Okay. So I just really need to distribute in then the negative 2. Negative 2 times 1 is negative 2. Negative 2 times positive square root 3 over 2 is negative square root of 3. Questions on that one? Sine or cosine? Cosine? Okay. I heard cosine first. So find me using half angles here instead of tangent, find me the cosine of 195 degrees. Go. So this is really the cosine of 390 degrees divided by 2. But 390 is on the unit circle, but really it's 30 degrees divided by 2, because that's the same spot. Okay?
Why is it 3?
What?
Why is it 3?
Because 195 times 2 is 390.
I use my tangent. Do that. Don't you have to add the 180? You do it 1/2.
Oh, I did get that.
Okay? Now, because my original 195 degrees is in quadrant number 3, that means that cosine is negative in quadrant number 3. So when I go to utilize my formula or my identity number 25, this is going to equal negative, because my cosine has to be negative, of the square root of 1 plus the cosine of u divided by 2. So that is the formula or the identity that I'm going to use. It's got to be negative out in front because 195 is in quadrant number 3. So then this becomes negative big square root 1 plus the cosine at 30 degrees. Here now, this is my angle u. Cosine at 30 degrees is root 3 over 2. Still all being divided by 2. Simplify the numerator. Simplify the whole fraction down to one fraction. What do we say this was the cosine of 195 degrees? Yep. You saying this right here? Here I went 2 over 2 plus the square root of 3 over 2 to get a common denominator. Here I keep change flipped. 2 plus the square root of 3 over 2 times 1/2. Here I took the square root of the top over the square root of the bottom.
Why is there still a 2 under the...
Which 2? This one? Or this one?
Once you like take the half out, then why does the 2 stay inside?
Because that's from the numerator.
But isn't like the 2/4 what's taken out?
No. Right here. Take the square root of the top over the square root of the bottom. So dividing by 2 is the same as multiplying by 1/2.
Yeah.
Okay? Good? Alright, now we're on your note sheet. Okay? So now we're going to add in the double angle identity. So far we've had sum and difference of angles and half angles. Now we're going to go with double angle identities. Okay? So this identity here now is the sine of 2u is number 21 on your identity sheet. Okay? So if I think of the sine of 2u as the sine of u plus u, then now I can apply identity number 19, which would say then that this is the sine of u times the cosine of u plus the cosine of u and the sine, or times the sine of u. And I put them in blue and green so you can see that we are really truly still applying identity number 19. So this really here is the sine of u cosine of u plus the sine of u cosine of u. Because I can rearrange any singular term as long as it's multiplication. Correct? Order doesn't matter in terms of multiplication. Okay? So if you have one sine of u cosine of u, and I give you another sine of u cosine of u, what do you have? 2 sine of u cosine of u, right? So you have 2 sines of u cosine of u, which is what we needed it to be. Okay? So that number 21 is now usable. I think we put it on this. Nope, didn't. Let's go on to number 2. Cosine of 2u equals cosine squared minus sine squared. These are all number 22 on your identity sheet. It's got 3 different identities. So let's figure this one out ourselves. Okay? So cosine of 2u would be the same as the cosine of u plus u. Utilizing now identity number 18, cosine of u plus u would become the cosine of blue u times the cosine of green u. Because it's plus, I need to switch this to minus in cosine. The sine of blue u, the sine of green u. Well, cosine of u times cosine of u. No. Cosine squared of u. Sine of u times sine of u. Sine squared of u. So that is option A on identity number 22. Now that we've proven option A, we can use option A to find the other two. Okay? So in the first one, so in option, this is actually option C here. This is actually option C here to go to 1 minus 2 sine of u. Okay? I am going to replace cosine squared of u with, from the hammer, option B in number 7. 1 minus sine squared of u. Does everybody see how I can make that change? Okay. 1 minus sine squared is 1 minus 2 sine squared. And that opens up option C in number 22. Don't think, did I put it on the next page or did I put it? There it is. So this is option 22B. If we do 22b, then we would say that the cosine of 2u is cosine squared of u minus sine squared of u. That was option A. And we can now, instead of replacing cosine squared, now we can replace sine squared. So we have cosine squared of u minus 1 minus cosine squared of u. Distribute in the negative 1. And that would give me cosine squared of u minus 1 plus cosine squared of u. Cosine squared plus cosine squared is 2 cosine squared of u minus 1, which is what we need. Tangent of 2u would be the same as tangent of blue u plus green u. This is going to be number 23, which would become utilizing number 20. So then this would become the tangent of blue u plus the tangent of green u all over 1 minus the tangent of blue u times the tangent of green u which would become tangent of u plus tangent of u is 2 tangents of u. Tangent of u times tangent of u is tangent squared of u. Where you're going to use the double angles, okay, you're not going to use the double angles to find trig value, unit circle values like we've been doing. Okay, what I mean by that is we're not going to use those to find like we did here, okay, where we found values of trig functions at specific angles. That's not where we're going to use them here. Where we're going to use them is on the back side of your note sheet there that I gave you, is we're going to use them to solve trig equations. Okay? So for instance, the sine of 2x equals the sine of x. Okay? We want to solve this one. So anytime that you see the sine of a double angle, like we have here, that automatically should go to numbers 21, 22, or 23. Okay? So in this particular case, the sine of 2x would be 2 sine of x cosine of x. And that would equal the sine of x. Now you've got to count trig, or different trig functions. Remember, if you have one trig function, you get it equal to that trig function and you solve it that way. If you have more than one trig function, you've got to get it equal to 0 and factor. Okay? How many trig functions do we have? 2, right? I see a sine and I see a cosine. Okay? Or I see a sine on the right side and I see sine cosine on the left side. Okay, so we've got 2 different trig functions depending upon how you're looking at it. So that's a get it equal to 0 case. So that's going to be 2 sine of x cosine of x minus sine of x equals 0. And now I have to factor. Can I factor anything out of that? A sine of x. If I factor out a sine of x, what's left over? 2 cosine x minus 1. Can I factor any more? Nope, don't believe so. So once I've got it factored, then I can set my factors equal to 0. And then I can solve those. Okay. Where on the unit circle is sine equal to 0? Zero and pi, do we agree with that? Where on the unit circle is cosine equal to positive 1/2? 5 pi over 3 and pi over 3. I thought I heard you say the pi over 3, but I couldn't quite, so I wanted to make sure. So all 4 of those then will make up our answer here to this one. So we've got 0, pi over 3, pi, and 5 pi over 3 as our answers to that equation. Okay? Give me a number 2, 3, 4, or 5. 4? Okay, that's a good one. I like 4. We'll save 5 for later. Get a shade on that one, just so we... Okay, all right. So, in number 4, we've got the cosine of 2x, so that automatically should say I'm going to need to replace that, correct? But if I go on my identity sheet and I'm looking at number 22, I've got 3 options. Which option should I choose for this particular one? Why the third one? Okay, so because I have another just regular sign in that equation, I want to get rid of all cosines. Okay, so my third option is the best. 1 minus 2 sine squared of x plus sine of x equals 0. How many trig functions do I have? Different ones, 2, right? Because I got a regular sine and I got a sine squared, right? So that means I need to keep it equal to 0. In this particular case, I'm going to get it 0 equals because I want to have a positive on my squared. So I'm going to shove everything to the left side. Excuse me, to the right side. Okay? One I know has to be 2 sine of x. The other one I know has to be sine of x. Yes? My only 2 choices there. Also, my only 2 choices are 1 and 1. There. I need the sine of x term in the end to be negative, because I've got a minus sign. So that's going to be a minus there and a plus there. If in your brain you need to do that makes sine of x, that makes negative 2 sine of x, and these 2 added together gets me negative sine of x, and there it is, you can do that too. Okay? But that's the check that I just do in my brain. So then 2 sine of x plus 1 equals 0. So 2 sines of x equals negative 1. So sine of x equals negative 1/2. And sine of x minus 1 equals 0. So sine of x equals 1. Where on the unit circle is sine equal to negative 1/2? Just 7 pi over 6? And 11 pi over 6. Where on the unit circle is sine equal to positive 1? Pi over 2. Okay. You now have everything that you need to do your entire homework packet, meaning you can do numbers 15 through 18. Okay. We'll do the other 3 tomorrow in class off of that note sheet, just so you are aware.